Okay, so now I am on activity 1, and what we're going to do is we're going to take different metals, and you'll see they look like a metal bar, and these are neutral metal atoms, and we're going to stick them into some different solutions. And so for activity 1, notice these are all nitrates, so they are completely soluble in water, which means the ions have separated. And in my first beaker, I'm going to have magnesium 2+ ions in solution. My second beaker, I have zinc 2+ ions in solution. My third beaker, I have copper 2+ ions in solution. And finally, I've got silver +1 ions in solution. And I'm going to pick these different metals and put them into each solution. And what you're going to do is record your observations for what happens. Okay, so we'll start with magnesium, solid pieces of magnesium metal, and click here to place the metals into the solution. So here goes the magnesium into these different solutions, and you're going to observe what changes happen. In some cases, there was not a reaction. So really only in the first beaker was there not a reaction. Something did happen here. We saw some metal plating on the outside of my magnesium bar. Something happened here. I see some metal plating on the outside of my magnesium bar, and something happened here. So if you watched carefully, something did occur there. I think I can go to the molecular scale reactions and see what happened. So if we try our magnesium, putting it into this reaction, and it said the water molecules and the nitrate ions, the nitrate are just spectators in this case, are not shown, just to simplify things. And what we are observing in our first beaker is really nothing seems to be changing. And we mentioned there really was no reaction in that case, okay? However, if I reset this and I take my magnesium and I put it into my zinc, what we see are the zinc ions that are in solution are exchanging electrons with the magnesium metal that's in the bar. It seems as though the zinc has plated onto the outside of the magnesium bar. So we gain a layer of zinc. And what you noticed is that magnesium actually gave 2 electrons to the zinc, and then some of those magnesium atoms then converted into ions and went into solution. And that happened kind of quickly, but we can go back. We can see step by step. So notice in this reaction that the electrons are transferred directly from a magnesium atom to a zinc 2+ ion. The chemical change that occurs can be represented by the following equations. Okay, so in one case, we have kind of a total molecular equation where we haven't split the ions up, but we see the nitrates, which are spectator ions. And then this is a net ionic equation where we've removed the spectator nitrate ions. You can't see the electrons being transferred in this equation, but it's implied because there was really an exchange of 2 electrons occurring. And if we look at oxidation numbers, we'll see why that is later on. Okay. And there it is again. So, it's taking us step by step. So this is an oxidation reduction reaction. When a zinc 2+ ion collides at the surface of the magnesium electrode, a magnesium atom releases 2 electrons to the zinc 2+ ion. The magnesium atom enters the solution as Mg2+. The oxidation half reaction, so oxidation is losing electrons. This is the half of the reaction where the magnesium is losing its 2 electrons and converting to an ion. And then a neutral magnesium atom loses 2 electrons and forms an Mg2+ ion. The oxidation number is changing. Okay, next step. A zinc 2+, and you'll notice that atom just got larger because it gained electrons, so its electron cloud got bigger. A Zn2+ from zinc to nitrate solution captures 2 electrons and attaches. Okay, so now we have zinc 2+, gaining 2 electrons to form a neutral zinc atom. And the magnesium goes into solution, and we've plated some zinc onto here. Okay. And notice in this reaction that the electrons are transferred directly from a magnesium atom to a zinc 2+ ion.